Hey, what's up, guys? This is Chung. So this time, LeetCode number 84, largest rectangle in histogram. So given like n negative integers representing the histogram's bar height, and where the width for each bar is 1, and you need to find the largest rectangles in this histogram. So for example, that's one. That's the 215623, and the answer is 10 because we have like the bar 5, the height is 5 times 2, right? The width is 2, and the answer is 10. So I mean the first uh, brute force solution is by of course is by enumerate all the possible start and ending point for the rectangles. And then for each of the start and end pair, we already have the width. And for the height, we just need to find the minimum height between that start and end point. So for that solution, it could be either O of uh, O cube, sorry, either n cube or n square, right? So n square basically we're just doing some improvements by forgetting the minimum height. So but even for the n square solutions for this problem, it will TLE. That's why we need to find a better solution. And so if you watch this example like closely, I think one of the observations you can find is that, so every time, right, when we have like a bar who is lower or this number is smaller than the previous one, then it's the time to go backwards to calculate the rectangles for the previously bar. And why is that? Because if we have like let's say we have some bars here, right? They just keep increasing and increasing until we have seen a smaller one. Let's say we have a like smaller bar right here. Then it means that at least for this one, for the previous one, for the previous bar, it cannot extend anymore, the rectangles, right? So which means that we have to go back to calculate that. And if we can, and for this kind of bar, right, we already have the height. And for to calculate the rectangles, if we have the height, all we need to know is the left and right. And for the right, we already know that. For the right boundaries, we already know it's the current bar. It's a current I or the I minus one because it's right here. And the only thing left is that how can we know the left the left boundary, which is a starting point of of the rectangles, right? Who has the height of this current one. And the left boundary actually is a stack, is the top element of the stack. Basically, we're going to use the stack to maintain uh, like an increasing bars. And the left boundary happens to be the stack minus one, right? So why is that? I'll give you some examples here. So let's say we have like this 1, 2, 3, and 4, right? The uh, and the height is, let's say we have 2, uh, maybe 4, 2, 4, 6, and here we have a 3, and then yeah, and here we have 1. So we have 1, and then this is 5. So at the beginning, right, we have 2, 4, and 6, that's we just keep adding this, pushing those index into the stack. And now we have 3. We have 3 is smaller than the stack -1. Then we just pop this 6 out, and and for the 6 we want to know the width for the 6 rectangle, for this rectangle that who has the height 6. And in this case, it's going to be the what? It's going to be the I, which is 4. Maybe the I minus stack -1, and then -1. So we do a -1 because the current I is 4, which is the one that's next to the 6. In this case, it's gonna be 1, right? So this is 1. That's why we have 6 here. And then we just continue comparing the top one with 3 here. So 4 is also greater than 3. That's why we pop this 4 out. And now for the rectangles, right, that has a height 4, same thing, right? The the right boundary is also the current I, right? And the left boundary is what? It's 1 in this case. It's also like it's also by using this formula, we have 4 minus -1 and then -1. So we have 2 here, right? That's why the total answer is 6. Sorry, it's 8. And the next one is 2. So 2 is smaller than 3. That's why we don't do anything. And now, right, we have 1 here, right? So for 1 is smaller than 3. That's why we pop 3 out. So now the height for 3 is what? It's so the width of the rectangle who has the height 3 is all the same, right? So 5 minus 1 and -1, which will be, this is 3. 3 times 3 is 9, right? Because I think it's easier to see it here, right? Because that rectangle is somewhere here. This is the rectangle. That's why the stack -1 always give us the left boundaries of the current rectangle. And that's exactly what we are going to do here. And so to do the coding here, so first I'm going to have like the height, right? The length of the height. And then at the beginning, right, we're going to have like put a -1 into the stack. So the reason being is that, uh, for the last bar in the stack, if we still want to use the same formula to calculate the width for that the last bar, we're going to use this -1 to do the calculation. So then we have I dot h in enumerate height, right? And then while stack -1 is not equals to -1, and h is smaller than the height of the stack -1, right? Then we just we pop that that bar. And so we have current I, since we're storing the index, right, in the stack. So we pop that index out, and then we calculate the width. So the width is going to be, like I said, is I minus stack dot -1 -1. Okay, and then we have answer equals to the max of the answer dot height current I times width. And then in the end, we append this current index to the stack. So after this while loop here, right, we have already handled the cases right in the middle, right? If there's like a decreasing right in the middle, for example, right, we have after this first while loop, we have 1, 2, and 3 left in this stack. So similar to take care of the last the last 3 bars left in the stack, we just need to do the similar thing. So basically, while stack dot -1 stack the top one is not equal to -1, and we don't need to do this the height check here because we need to pop everything out. But we'll still use the same logic, same like formula. The only difference is that now we don't have I here because now since we have everything and we need to use n because whatever left the right boundaries is always n. Yeah, and yeah, that's it. So in the end, I simply return the answer. Cool. So if I run, uh, oh, so let's run the code here and submit. Yeah, so it works. I mean the time complexity for this solution is what is it's just the O of n because we'll be pushing the we'll, we'll be pushing and popping the bars only one time into the stack, and then that's why we have on. Here is also on, and yeah, I think that's it, right? So just I mean to recap real quick. So to solve this problem, the main idea is that uh, whenever we have like a decreasing bar here, it means that we need to go back to calculate the previous bars because those bars cannot be extended anymore. And to calculate that bars, we want to find the left and right boundaries. So for the right boundary is the current index, but for the left boundaries we need to maintain that. And and then we find out that right we can use a stack and the top element of the stack for will be the left boundaries for that bar. And that's how we come up with this kind of solution. And yeah, and thank you so much for watching this video, guys. Stay tuned. See you guys soon. Bye bye.